Kata is something you practice, not something you watch. Read the lesson, write the code yourself, then review what you wrote. This video is the reference you come back to afterwards. A model can produce this code in seconds, and the reason to write it by hand is to keep the judgment that tells you whether the code is any good. The function and effect returns is the most underused line in React, and the name people give it is part of why. Calling it the unmount handler makes it sound like a last write, something that runs once when the component disappears. It runs far more often than that. It runs before every single rerun of the effect, and then once more at the end. Once you see it as the undo half of a pair, rather than a teardown step, the patterns in this lesson stop being 5 separate recipes, and a debounce turns into 3 lines with no library. 4 failures on screen, and they are all the same failure wearing different clothes. Something was started and never stopped. A timer keeps firing after the component has gone. A listener holds a reference to a closure that holds a reference to state, so nothing can be collected. A slow response arrives after a fast one and overwrites newer data with older data. And each of those compounds, because the component that leaked one timer will leak another every time it mounts. The rule underneath is one sentence. If an effect starts something, its cleanup stops it. That is not a style preference. It is what makes the effect safe to run twice, which React will do. Timers are the clearest case because you can hear them. Set an interval in the effect, clear it in the cleanup using the handle the setter returned. Miss the cleanup and the interval outlives the component that created it, still holding whatever it closed over, still firing into a callback whose component no longer exists. The playground at the end of this lesson has exactly that running, and it shows the part that makes it worse than a single leak. Mount the component again, and there are 2 intervals, then 3 all ticking together. Listeners on the window or the document are the ones that outlive components most often because the object they are attached to never goes away. Add in the effect, remove in the cleanup. The one detail that silently defeats this is the reference. Remove event listener finds the handler by identity, so it has to be handed the same function object that was added. Define the handler inside the effect, use it in both calls, and that is guaranteed. Define it inline in both places, and you have added a listener and removed a different one, and the code looks correct. A socket connection, a store subscription, a database listener, all the same shaping. Open it on the way in, and the cleanup closes it or calls the unsubscribe function that was handed back when you subscribed. That return function is worth noticing as a convention. A well-designed subscribe API gives you its own undo, and your cleanup is then a single line calling it. When an API does not do that, that is a small signal about how carefully it will handle the rest. This one prevents a bug that is genuinely hard to reproduce and easy to ship. Search as the user types, and a request goes out per keystroke. Requests do not come back in the order they were sent, so a slow response for an early query can land after a fast response for a later one, and the user sees results for something they finished typing 3 letters ago. Cleanup is what fixes it. Because the cleanup for the previous effect runs before the next one starts, you can have it mark that request as no longer wanted, and the handler checks that flag before touching state. An abort controller does the stronger version, canceling the request itself, so it never comes back at all. Either way, the ordering guarantee is what you are relying on, and that is the whole reason cleanup runs before the rerun rather than after. This is the pattern that shows the mechanism most clearly, and it is my favorite thing in this lesson. Put a timeout in the effect that does the work after a delay and clear that timeout in the cleanup. Now type. Every keystroke changes the dependency, so React runs the cleanup first, which cancels the pending timeout and then sets a fresh one. The work only ever happens once the user stops long enough for a timeout to survive. That is a debounce, and there is no library, no ref, and no timer bookkeeping in it. It falls straight out of cleanup running before the next effect. The 2 blocks on screen are the same effect with 1 line of difference, and it is the difference between a timer that stops and a timer that runs until the page is closed. Worth adding 2 more that the page does not list. returning the result of a call rather than the function itself, which runs your teardown immediately and cleans up nothing later. And a cleanup that reads a value from state, which sees the value from the render it was created in, not the current one. That second is not a bug in itself. It is often exactly what you want, but it surprises people the first time. Cleanup runs before the next effect and on unmount, which means it usually runs many times, not once. Anything started gets stopped. Timers, listeners, subscriptions, requests. Use the same function reference for adding and removing a listener. Use a flag or an abort controller to stop an out-of-date response from writing to state. And the same ordering that makes cleanup useful for teardown makes debouncing almost free. Here is the leak running and the console is where you watch it. A small timer component starts an interval in an effect and returns nothing at all. Press the button and the component unmounts. The log keeps going. The component is gone from the tree, React is no longer rendering it, and its interval is still firing every second, holding on to the closure it was created with. Now press the button again to mount a fresh one. That is 2 intervals. Again, and it is 3, all ticking in the same console. Nothing errors, nothing turns red, and the tab quietly does more work every time. This is what a leak looks like in practice, not a crash, just a page that gets heavier the longer someone uses it. The same component with one line added. The effect keeps the handle that the interval setter returned, and the function it returns clears it. Now unmount and the log stops immediately. Mount again, and there is exactly 1 timer, however many times you cycle it. Watch what the console prints on the first mount in development though. The setup runs, the cleanup runs, and the setup runs again. That is strict mode checking this very thing. The first variant fails that check by leaving a timer behind, and the fact that this one passes it is the same fact that makes it safe. The last variant is the listener version, and it is short enough to read in one go. The handler is defined inside the effect, added to the window, and removed by the cleanup using that same name. The dependency array is empty because the handler closes over nothing that changes. That last point is the one to carry into your own code. The moment the handler reads a piece of state, the empty array is wrong. That state joins the array, and the listener is then removed and re-added whenever it changes, which is correct and is exactly what the cleanup makes possible. The model to keep is a pair, not a life cycle. Every effect that sets something up returns the line that tears it down, and React runs that line before every rerun and once at the end. Read your effects looking for the pair. If you can find the setup and not the undo, you have found either a leak or a race, and usually the console will show it to you inside a minute. The kata is the part that matters. Open the lesson, write the code yourself, then read back what you wrote and judge it. The link is in the description, and that practice is what keeps the skill yours.